Hello class, welcome to our lesson today. We're going to be looking at section 13.2 in your textbook. We've actually looked at the topic that we're going to deal with today, slope, before throughout the semester, but it can't hurt to kind of go over a few things again and maybe focus in on what the slope formula is actually telling us. This information is in your textbook in section 13.2. This talks about the slope of a line. First off, slope is denoted by the letter M. Okay, so excuse me, anytime you see slope in a textbook or on homework or things like that, you should denote it with the letter M. And remember, it's rise over run, or the change in y over the change in x. So rise over run, or change in y over change in x. And what this means is we take the difference between the y's, so y2 minus y1, over x2 minus x1. So there's a lot of ways that you can set this up. The key is that x1, y1, remember, just like distance formula is an ordered pair, and x2, y2 is the second ordered pair. When you have graphs, when you have ordered pairs, when you have pictures, when you have tables, there's some different options that you have in order to find the slope. But all in all, you're trying to find the rise over the run, the change in the y over the change in x. Remember, the lines always go from left to right. So a positive slope would be going in the upward direction from left to right, and a negative slope would be in the downward direction from left to right. Since mathematics always goes left to right in terms of a number line, you have to read the graph that way as well. Okay, the first thing we're going to look at in terms of finding slope is just looking at a picture. So if we're given a picture, you can basically just do the rise and run by counting. So for this picture here, I'm going to basically make a right triangle, much like I did with the distance formula. So I figure out how far up and how far over I'm going in order to find the slope. So from this point, I'm going up 2 and then over to the right 6. And so my slope is 2 over 6. And remember, you always simplify that down, so that would be 1/3. For the second one, instead of going up and over, I'm going down and over to the right. So I'm going down 1 and then to the right 5. So this would be a slope of negative 1/5. That negative sign could be in the numerator or it could be out front in front of the fraction. Either of those options are fine as you're trying to find slope. Notice the first slope is positive, while the second slope is negative. The next question, I start from the left point and go to the right point. I'm going up 5 if I count 1, 2, 3, 4, 5, and over to the right 2. That would give me a slope of 5 over 2. Now that's an improper fraction. You could write that as a mixed number if you wanted. You could write as a decimal. But in general for your classes as you move forward, leaving that as an improper fraction will be just fine. The next question, notice I didn't draw a triangle because I didn't go up or down at all. I just went over to the right 7. So that would mean my rise, okay, the change in the y is 0, divided by 7, which is still 0. This makes sense because I didn't rise at all or fall any from the first point to the second point. So my slope is 0, which means it's a horizontal line. If you want more information about vertical lines, our focus isn't going to be as much on the vertical lines right now, but a vertical line would be an undefined slope because it would be rising but not running left or right. So that would make this the kind of its reciprocal, which would be 7 over 0, and since you can't divide by 0, the slope would be undefined. The next setup we're going to look at is with two ordered pairs. Now remember, your first option is you just find the change in y and the change in x. So I could find the difference between these two y values, which is kind of what we did earlier in the year, and the difference in the two x values. You could also graph it to make it look like these types of questions. The third option is you use the slope formula, which is really just change in y over change in x. y2 minus y1 over x2 minus x1. Much like the distance formula, it doesn't matter which ordered pair is x1 and y1 as long as you're consistent. So the y2 minus y1 would be 8 minus 3, which is 5, which is the same as the difference between them. 5 minus 1 for the x values would be 4, and my slope would be 5/4. That means it's rising 5 spots and moving to the right 4 from the first point to the second point. For the next question, I used y2 minus y1, so 1 minus 4 is negative 3. But then the key thing with the distance idea and slope and finding the range or the difference between the two numbers is that it's 7, not minus 2, it's minus negative 2. And minus a negative would become plus a positive. So negative 3 divided by 9 would be negative 1/3. This slope would be going down 1 and to the right 3 as opposed to up 1 and to the right 3 because it has a negative slope. Make sure you're paying attention to this double negative. Some of you, when you did distance formula, you had the issue with this double negative, and you want to make sure that that looks a little bit better for your lesson today. For the next one, y2 is -1 minus y1, which is also -1. -1 minus a -1 is 0 because it's really keep, change, -1 plus 1 with the minus a negative. And that's 0 over 11 for the bottom being from 3 to -8, or the difference in those two numbers, which is 11. Your slope then is 0, which remember 0 is a horizontal line like the previous example we did here. So horizontal lines, 0 slope, vertical lines, undefined slope. One other thing that you might see is just a table of values. So notice here I've got x and y, and it should be a consistent slope each time. So one way you could do this is to find two-ordered pairs. So this is 1, 3 for xy, and 4, 7 for the other xy, and that's x1, y1, x2, y2. You should get 4/3 as an answer when you do that. The other option here is you figure out what's happening each time in the x's. This works well with linear graphs or things that deal with slope. So from here, 3 to 7 is +4, 4 to 11 is +4, 11 to 15 is +4. From 1 to 4 is 3, 4 to 7 is 3, etc. And so the change in the y numbers is 4, and the change in the x numbers is 3. That's another way that you can understand how slope works. For the next scenario, I picked two-ordered pairs. I picked the first two again, 2, 10, and the 0.47. x2 minus x1 and y2 minus y1 is what I'm looking for. But remember, the y values have to be in the numerator, x values in the denominator, because slope is a measure of how steep a graph is. So 7 minus 10 is -3, and then 4 minus 2 is 2. There is always a little bit of confusion among students. Do I put the negative in the numerator? Do I put it in the denominator? Do I put it out front? If you put it in the numerator or out front, that's really the same. Technically, if you put it in the denominator, it's the same. The issue is, what if both of them are negative? So let's say it's -3 over -2. Well, a negative divided by negative, you have to make sure that you state that that's a positive answer. Another way that you could go about this question is the change in y is going down 3 every time, so that would be -3. And the x value is going up 2, so that would be +2. Either way, I should get a negative slope of -3 over 2. Okay, your homework today has a lot of pieces. It's kind of grouped together amongst some different types of questions. You want to make sure that you're trying the formula out, this y2 minus y1 idea. Just try it out and see how it works for you. On some of the graphing ones, you could probably count up and over. But if you're given two-ordered pairs, what we want to see is some of the formula pieces, especially on the later questions on closer to 18. So the first group is more graphing, so you can probably just count up and over. But the second half of the 7 through 18, for sure, you want to make sure you're showing a little bit of work about how to find those answers. And then these last group of questions, 37 through 40, they deal some things with proportions. Make sure that you show your work on how you solve those. It can be a simple cross multiplying, but make sure you have some work to support all of your answers on your homework. Have a good day, everyone.